In this video, we'll try to understand how to find out the beam reactions in case of a simply supported beam carrying moment and a uniformly distributed load. So as shown over here, we are having a u.d.l of 4 kN per meter acting for a distance of 2 meter from the left hand support as well as from the right hand support, as well as it also carries a couple of 8 kN and the couple arm is 1 meter plus 1 meter, that is total 2 meter. So for this particular arrangement, we have to find out the beam reactions. So our first job is we will convert this uniformly distributed load into point load acting at the center of this rectangular distribution. Over here also we'll convert this u.d.l into point load acting at the center, and then we'll convert this couple which is acting into a moment which is acting at the point C. So let us see the process over here. So first we'll draw the arrangement of the given particular beam. So as we have already discussed, it is having the total span length of 8 meter and it is also carrying u.d.l of 4 kN per meter at a distance of 2 meter from both the supports. Now the reactions which are acting at point A and B, they are shown, and also the u.d.l which we have converted into the point load. So as you can see over here, this is 4 kN per meter. So that is for 1 meter length, the load that is acting is 4 kN. Then for 2 meter length, the load that will be acting will be 4 into 2, and it will be acting at the center of 2 meter length, that is 1 meter. Similarly, for this 4 kN per meter, it is 4 into 2 acting at the center of 2 meter length, that is 1 meter. And this 8 multiplied by 1 plus 1, that is 2. So 8 into 2, that is 16. And the arrow of this particular force, that is 8 kN, is going towards this another force in the clockwise direction. Similarly, you can consider that this arrow is going in this particular direction, that is clockwise direction. So the direction is clockwise. So it is 8 into 2, that is 16 kN meter. So we can say that the equivalent free body diagram for the above diagram will be nothing but 8 kN load acting at a distance of 1 meter from the left hand support. Similarly, 8 kN load acting at a distance of 1 meter from the right hand support, and at the center there is a moment of 8 into 2, that is 16 kN meter. Now applying the conditions of equilibrium. So first condition that we are applying over here is summation of forces in y direction is equal to 0. Upward forces, they are considered as positive, whereas downward forces, they are considered as negative. So RA and RB, they are acting in the upward direction. This 4 into 2, that is 8 kN acting in the downward direction, and this 4 into 2, that is 8 kN, that is also acting in the downward direction. So total force is RA plus RP is equal to 16 kN. The another condition of equilibrium is summation of moments is equal to 0. Clockwise moments we have considered as positive, whereas anti-clockwise moments, they are considered as negative. Now taking moments about point A, so start with this RB. So the arrow, upward arrow of this reaction RB will produce anti-clockwise moment about A, and the perpendicular distance from B up to A is 2 plus 2 plus 2 plus 2, that is 8. So that is minus RB into 8. So as it is in the anti-clockwise direction, the negative sign is there. This 4 into 2, 8 kN will produce clockwise moment about A, and the perpendicular distance from this point up to A is 2 plus 2 plus 2 plus 1, that is 7. So that we have indicated over here. 8 into 2, that is 16 kN meter, that is already a clockwise moment that is acting. So that is shown over here. And this 4 into 2, that is 8, and the arrow of this about A will produce clockwise moment. So 8 into 1. So that is also indicated over here. So total is this 8 into 7, that is 56 plus 16 plus 8. So that total is 80, and transfer is negative, minus RB into 8 on this side. So it will become 8 RB. So you'll get the value of RB, that is 80 divided by 8, that is 10 kN. Now substitute this value of RB in equation 1. So from equation 1 we can say that RA is equal to 16 minus RB, and substitute the value of RB, that is 10. So reaction at A will be 6 kN. So in this way we can find out reactions at A and B. So RA value is 6 kN and RB is 10 kN. Thank you very much for watching. Also watch the videos on shear force and bending moment diagram on our channel. Thank you very much.